Kilauea's 8-hour monster eruption just shattered every record in volcanic monitoring history. 2,000-foot towers of molten rock exploded into the Hawaiian sky. Lava fountains were so massive that monitoring cameras had to zoom out until they ran out of frame. But here is what has scientists in absolute panic. This may not even be the peak. For 13 months, Kīlauea has erupted 41 times. Each episode is coming faster. Each one is growing stronger. What used to reach 1,000 feet now surges to 2,000 feet. And scientists are issuing an urgent warning that is sending shockwaves through the entire volcanic monitoring community. They are predicting a larger episode this week. But the most terrifying part? The ground beneath Hawaii is not releasing pressure, it is accumulating pressure. Tilt meters show the volcano inflating between eruptions, but never fully deflating back to where it started. Earthquake swarms are striking with increasing frequency. Magma is rising from 30 miles deep, and underground chambers are filling faster than they can empty. Something is building beneath the Big Island. Something big. Are we watching the buildup to Hawaii's most catastrophic eruption in modern history? Or is this the new normal that scientists never predicted? January 24th, 2025, at 3:52 in the morning, Hawaii Standard Time. Everything changes. Kilauea's north vent transitions from overflow to continuous discharge. Lava fountains begin to grow as pressure releases from the magma chamber below. Observatory staff increase monitoring frequency across all sensor networks. This is no longer routine activity. By 10:15 a.m., tilt meters buried beneath the summit record a sudden deflation. The mountain is exhaling. Magma is moving. Scientists recognize the signature immediately. A major eruptive episode is imminent. Emergency protocols activate across Hawaiʻi Volcanoes National Park. Rangers begin clearing visitors from vulnerable areas. At 11:10 in the morning, summit seismometers detect a tremor that is rapidly increasing. The ground shakes with the movement of molten rock rising through underground pathways. Park officials scramble to evacuate observation points. The volcano is about to unleash something unprecedented. 12:10 p.m. Both north and south vents erupt simultaneously. Lava fountains reach 500 meters, or 1,640 feet, according to initial Hawaiian Volcano Observatory measurements. The dual fountains create a spectacular display visible from points miles away, but the intensity keeps building. U.S. Geological Survey monitoring cameras positioned on the crater rim struggle to capture the full scale. Operators zoom out repeatedly as the fountains climb higher. 1,640 feet becomes 1,800 feet, then 1,900 feet. The towers of molten rock surge upward with explosive force that has not been witnessed during any of the previous 40 episodes. By mid-afternoon, the fountains reach 2,000 feet. Ash and tephra rain down across the entire Halemaumau crater. Chunks of molten rock the size of cars arc through the air before crashing back to Earth. A massive convection column pulls volcanic glass and ash 20,000 feet into the atmosphere above the Big Island. Thermal readings spike off the scales of monitoring equipment. The eruption sustains this devastating intensity for 8 continuous hours. This is not just another eruption, this is the biggest yet. But scientists are issuing warnings that terrify even veteran volcanologists. The data suggests this monster eruption is still not the main event. Deep beneath Kilauea's summit, tilt meters tell a disturbing story. These sensitive instruments measure the slightest changes in ground angle as magma fills or drains from underground chambers. The data reveals a pattern that has scientists deeply concerned. Between each eruptive episode, the baseline tilt level is rising. The volcano is not releasing pressure, it is accumulating pressure. The cycle seems simple. The volcano inflates, it erupts, it deflates, but it never deflates all the way back to where it started. Compare the tilt charts from December 2024 to January 2025. Each episode discharges massive volumes of lava. Fountains reach record heights. Rivers of molten rock flow across the crater floor. Yet the pressure release is not enough. The floor of each deflation event is getting higher. Less total pressure escapes with every eruption cycle. Look at the 1-year tilt data. The trend is unmistakable. A steady upward climb interrupted by sharp drops during eruptive episodes. But those drops are becoming shallower while the peaks between episodes grow taller. Scientists describe it as a breathing rhythm. The volcano inhales, filling a smaller surface chamber from a much larger deep magma source. Then it exhales through violent eruption. Inhale, exhale, repeat. But the breathing is becoming labored. The exhales are not emptying the lungs completely. Think of it like rivers of molten rock flowing beneath the surface. Multiple underground streams converge into chambers that must find release. The supply is increasing, while the discharge capacity remains essentially constant. Pressure builds. Something has to give. The previous episode ended unusually quickly compared to historical patterns. Episode 41 shows sustained discharge, which suggests an increased magma supply rate. Multiple monitoring stations detect synchronized activity, indicating movement from great depth. The conclusion is direct and urgent. Kīlauea is not relieving its pressure efficiently. The pattern suggests preparation for something much larger. 41 episodes in 13 months represents a frequency never documented in modern volcanic monitoring. The previous eruptive episode ends. Tourists at the crater rim begin packing up cameras and phones. They prepare to walk back to the parking lot. Then the ground moves. A magnitude 4.4 to 4.6 earthquake strikes directly beneath their feet. The timing is not coincidental. The volcano speaks through seismic waves as pressure redistributes through underground chambers. What follows that earthquake is a massive discharge episode and fundamental pattern changes that scientists are still analyzing. Then comes the swarm. Dozens of tremors cluster at Kilauea's summit over the following days. Small earthquakes, magnitude 2.0, 2.1, and 2.2. Individually unremarkable. Together, they tell a story of magma on the move. Depth analysis reveals the critical detail. These are shallow earthquakes under 2 kilometers deep. Some occur less than 1 kilometer beneath the surface. This is not deep magma rising from the mantle. This is near-surface movement, molten rock filling pathways and chambers just beneath the ground where visitors walk. Satellite imagery captures the surface evidence. Giant cracks scar the volcanic slopes. Shadows reveal fissures extending hundreds of feet across barren lava fields. At the crater rim itself, ground cracking forces Hawaiʻi Volcano's national park officials to expand cordoned-off areas. Sections where tourists walked freely just months ago now sit behind barriers and warning signs. Rangers explain the reality to disappointed visitors. In the event of a major earthquake, entire sections of the crater rim could collapse into the caldera below. Seismometer arrays detect sustained tremor beneath the surface. Not discrete earthquakes, but sustained vibration. The sound of magma moving through rock, friction, pressure, expansion. The mountain groaning under stress that continues building. The context matters. In 2018, Kilauea's summit collapsed. The crater floor dropped hundreds of feet as magma drained away. Since then, the caldera has been refilling episode by episode, but green olivine crystals mixed into the erupted lava reveal magma sourcing from 30 miles below the surface. Fresh material from deep within Earth's mantle is reaching the eruption vents through pathways that are opening wider. Pele's hair falls from the sky. These are not soft strands, but razor-sharp threads of volcanic glass, stretched thin by lava fountains and carried on the wind. Highway 11, west of Hawaiʻi Volcano's National Park, becomes dusted with glittering fragments that look beautiful, but are deadly to touch and to breathe. Reports come in from Volcano Village just minutes away from the eruption site. Tephra accumulates on car windshields. Ash coats outdoor furniture. Residents wake to find a thin layer of volcanic debris covering everything outside. The wind shifts, and the hazard zones shift with it. What was safe an hour ago becomes dangerous as atmospheric conditions change. The volcanic smog, also called VOG, spreads across the Big Island. Sulfur dioxide concentrations spike to hazardous levels in communities downwind from the summit. Residents with asthma struggle to breathe. Emergency rooms prepare for respiratory cases. Health officials issue advisories. Stay indoors. Seal windows. Use air filtration if available. The invisible threat spreads farther than the visible ash. Carbon dioxide and water vapor are released in massive quantities from the vents. The gas plume rises and disperses, but near the crater, concentrations can be lethal. This is why Hawaiʻi Volcanoes National Park closes access to the Halemaʻumaʻu crater rim during active eruptions. No tourists allowed, no exceptions. The elevated viewing areas, miles away, become the only safe observation points. Pele's hair tangles together on the ground like tumbleweeds. Wind rolls these clusters across roads and into yards. Children are warned not to touch them. The glass fibers can penetrate skin. Inhaling fragments can damage lungs, causing microscopic cuts that do not heal easily. Tourism operators have canceled helicopter flights, as ash makes flying unsafe. Ash poses risks to aircraft engines. Hotels in the area are managing cleanup and addressing guest concerns. Agricultural operations worry about VOG damage to sensitive crops. Coffee farms, macadamia orchards, and tropical fruit growers, all downwind from the summit, are vulnerable to volcanic haze. Communities are preparing for what scientists say is coming this week. Emergency shelters are on standby, ready to open if needed. Evacuation routes are being reviewed and updated to ensure residents can leave quickly and safely. Inside the Hawaiian Volcano Observatory, scientists work 24-hour rotating shifts. Multiple camera systems positioned around the crater rim feed live data. One camera was damaged in a previous eruption when a sideways blast knocked it offline. The footage went viral. Now backup systems ensure continuous monitoring. Tilt meters are buried at multiple depths. GPS stations measure ground deformation down to millimeters. Seismometer arrays detect every tremor. Gas monitoring stations measure sulfur dioxide emissions. Satellite radar interferometry tracks surface changes from space. The data flows constantly. Scientists analyze patterns in real time. Forecasts update every few hours. After 41 eruptions, they are learning the volcano's behavior. They are recognizing warning signs. They are understanding the rhythm, but Kīlauea still surprises them, and right now, the data is showing something that demands immediate attention. All warning indicators are flashing simultaneously. Earthquake frequency is increasing dramatically. Sustained inflation is occurring without adequate episodic relief. Gas emission composition is changing, suggesting new magma types. Ground deformation is accelerating beyond current rates. Lateral magma movement is being detected. The potential exists for new vents or fissures in unexpected locations. Scientists are watching a specific threshold. When accumulated pressure exceeds a critical point, catastrophic release becomes inevitable. Computer models based on current data are projecting a larger episode within days. Some scientists suggest fountains could reach 2,500 feet or higher. Others warn about duration, with potential for a sustained eruption lasting days instead of hours. The possibility exists for lava flows breaching Halemaʻumaʻu crater boundaries. Historical precedent supports their concerns. The 1959 Kīlauea eruption, the 2018 Lower East Rift Zone event that reshaped the island. Both followed similar pressure accumulation patterns. The uncertainty remains in exact timing. Predicting the precise hour is impossible, but the certainty is absolute. This pattern is unsustainable. Something must change. Scientists are issuing direct warnings to authorities and communities across the Big Island. Two possibilities exist: gradual pressure release through continued episodes, or a catastrophic single massive eruption. This week is critical. The volcano holds its secrets, but the monitoring data suggests the answer is coming soon. Hawaii sits atop the Pacific Plate's most active hotspot. This is not a volcano in the traditional sense, but something deeper and more powerful. A mantle plume, a column of superheated rock rising from the boundary between Earth's core and mantle nearly 2,000 miles below the surface. This is not plate boundary volcanism where tectonic edges grind together. This is an intraplate heat source that burns through the crust from below. The Pacific Plate moves northwest at roughly 3 inches per year, while the hotspot stays fixed. The result over millions of years is the Hawaiian island chain. Each island is a monument to the plume's persistent heat. The Big Island is the youngest and most active, located directly above the plume's center, where temperatures reach levels that melt solid rock into flowing rivers of lava. Magma erupting from Kīlauea measures 2,100 degrees Fahrenheit. Hot enough to instantly ignite anything organic. Hot enough to glow bright orange in daylight. The composition matters. Basaltic lava is low in viscosity, so it flows and allows sustained fountaining rather than explosive eruptions. This is why Hawaii erupts differently than Mount St. Helens or Vesuvius. The magma flows instead of exploding. Dissolved gases expand and drive fountain heights skyward with devastating force. Multiple vents at Kilauea connect to a common chamber system below. North and south vents fountain simultaneously because they tap the same pressurized reservoir. The critical factor scientists are tracking is chamber refill rate, accelerating based on tilt data. More magma is arriving from depth. Faster replenishment is occurring between discharge events. Beneath the visible eruptions lies an invisible network, lava tubes. Lava tubes are underground conduits formed when flowing lava surfaces cool and harden, while the interior remains molten. The Big Island is honeycombed with them. Hawaiian Acres, a populated area on Mauna Loa's slopes, sits above extensive tube systems. During eruptions, these pathways activate, and molten rock flows through darkness beneath homes and highways. We live on the thin, brittle crust of a molten planet. At 100 kilometers depth, rock glows hot enough to melt steel. Kilauea is a window into that interior heat engine. This volcano will not be tamed. Tourism drives the Big Island economy. The volcano is both an attraction and a threat. Hotels near Volcanoes National Park see bookings fluctuate with activity levels. Helicopter tour companies depend on safe viewing opportunities. When eruptions intensify, flights get canceled and revenue drops. Right now, tourism operators are calculating risk versus reward for this week. Some are canceling all tours preemptively, based on scientific warnings. Others maintain operations, but monitor conditions minute by minute. The agriculture sector faces catastrophic potential losses. Coffee farms are already experiencing fog damage. Macadamia orchards sit vulnerable to prolonged volcanic haze. Tropical fruit growers watch wind patterns obsessively. Economic calculations show millions in potential losses if a larger eruption occurs. Insurance companies review policies and calculate exposure. Real estate markets grow nervous as property values near volcano zones fluctuate. Emergency response costs are mounting. The National Guard stands ready on standby. FEMA coordinates with state officials. Resources are being positioned for potential mass evacuation scenarios that could unfold with hours of warning or less. For Native Hawaiians, this is Piali's domain. The volcano goddess is making her presence known. This is not an enemy to fight, but a force to respect. Cultural teachings emphasize balance. You do not control Pele, you honor her. Traditional ceremonies and offerings are being made across the island. Community leaders counsel respect for the ancient cycle of destruction and creation. Residents check evacuation routes and update emergency supplies. Schools review crisis protocols. Hospitals prepare for a potential influx of respiratory cases or injuries. The waiting is the hardest part. Everyone watches the same data feeds, the same webcams, the same updates from scientists, some with wonder, some with worry. The island has survived eruptions before, But never this pattern, never this frequency, never this intensity, never this acceleration. Communities across the Big Island unite in preparation. Emergency phone trees activate. Neighbor checks on neighbor. This is how Hawaii faces the volcano, together. But the question burns in everyone's mind. What will this week bring? The 8-hour monster eruption that just occurred may be merely the opening act. Scientists are unanimous. The data points to a larger episode this week. 41 eruptions in 13 months have built to this moment, each one coming faster, each one growing stronger, each one adding pressure that refuses to fully release. Tilt meters show the mountain breathing with a labored rhythm, inflating between episodes, but never deflating back to baseline. Seismometers detect earthquake swarms striking with increasing frequency. Shallow tremors, less than 1 kilometer beneath the surface, where communities live and tourists walk. Gas sensors record changing emission compositions that signal fresh mantle material rising from 30 miles deep. The numbers tell a story that cannot be ignored. What reached 1,000 feet in early episodes now surges to 2,000 feet. Monitoring cameras zoom out until they run out of frame. Chunks of molten rock the size of cars arc through the Hawaiian sky. Ash columns climb 20,000 feet into the atmosphere. And the pressure keeps building. Communities across the Big Island prepare for what scientists say is inevitable. Emergency shelters stand ready. Evacuation routes are reviewed. Hospitals stock supplies for respiratory cases. Tourism operators cancel flights. Agricultural operations brace for devastating fog damage. Native Hawaiians honor Pele's power while respecting the ancient cycle that built these islands from the ocean floor. The question is no longer if something bigger happens, but when and how severely. This week could rewrite volcanic history for the Hawaiian Islands. Whether this escalates to a catastrophic mega eruption or continues as progressive episodes, one certainty remains clear through all the uncertainty. The Big Island's volcanic fury is far from over. We are witnessing Earth's raw power in real time. The thin crust beneath our feet separates us from the molten interior that makes up most of our planet's mass. Kīlauea is speaking, the data accumulates, scientists analyze, communities hold their breath, and nature is about to show us what comes next. Is Hawaii ready for what Pele has planned this week?